Okay, so if you remember what we were discussing last time. So if x is monotonically increasing sequence and you choose if xnk is a subsequence which converges to number alpha, then original sequence is convergent. Right? Because in general, if xn is a sequence, if some subsequence is convergent, then it is not true that xn is convergent. So, right, if some subsequence is convergent, then it is not true that xn is convergent. Right? So answer is no. So if there are two subsequences such that both converges to same limit, then can we say that xn is convergent? So that is also not true. Correct? Do you agree what we discussed last time?
Yes, sir.
Okay. But now if xn is monotonically increasing and if some subsequence is convergent, if at least one subsequence is convergent, then original sequence is also convergent. That we were discussing. Suppose xn is monotonically increasing and therefore xn is less equal xn plus 1 for all n. Suppose xnk is a subsequence. There are many. So suppose this particular subsequence is convergent and converges to alpha, then we want to prove that the limit of xn is alpha. Limit of xn is alpha. So what is our strategy? What is the assumption? Xnk is a subsequence which converges to alpha. Our aim is to prove that xn converges to alpha. Right. So what is our claim? So we claim that given epsilon, there exists k. We claim that there exists k such that xn minus alpha is less than epsilon for all n greater equal k. So this is our claim, correct? Because our claim is that limit of xn is alpha. And what is assumption? The limit of some subsequence is alpha. That is our data. Okay, how to start this? How to start the proof? As we discussed last time, ki, if you look at this alpha and you look at alpha epsilon neighborhood of alpha, since tendency of sequence is increasing, even some term is inside this neighborhood, all terms are inside. Right? So how to start the next part? Right? So given epsilon, we want to find k. Yes, is it clear what we want?
Yes, sir.
Given epsilon, now we want to produce k. But what is assumption? Ki x and k converges to alpha. So given that since limit as k tends to infinity, x and k is alpha. So by definition of limit for this epsilon, there exists there exists some what we can say k1, right? There exists k1 such that xn k minus alpha is less than epsilon for all k greater than or equal to k1. Okay, so that is minus epsilon less than xn k less than epsilon for all k greater equal k1. What does it mean? Okay, minus alpha is there. So alpha minus epsilon less than xnk less than epsilon plus alpha for all k greater equal k1. This is just definition applied to limit of subsequence, right? Okay, now you tell me what is the situation. Alpha is here and alpha minus epsilon is here. Alpha plus epsilon is here. And what the previous step suggests, for k greater equal k1, that means look at the x n k1. Right. What is the first choice for k? What is the list or initial choice for k? Key onwards, this is true. K1, right?
K1.
K1.
So after K1, everything is in between alpha minus epsilon and alpha plus epsilon. So therefore, the first possible choice is xn suffix K1. So K1 is a particular number. Suppose K1 is 10, then xn K1 is x n10, and n10 is a particular term. But what is the tendency of sequence? Increasing, right? Monotonically increasing. And therefore, what is the next choice for K1? xn K1 plus 1. Next choice for K. Right, next term in the subsequence xn K1 plus 1. It is the next term. But in between there are some terms of subsequence, original sequence, which are deleted actually when we look at subsequence, right? So in between terms, if you look at some term which is in between xn K1 and xn K1 plus 1. So xm, what is the relation between xn K1, xm and xn K1 plus 1? What is the relation? Is a relation here.
XM lies between Xn K1 and Xn K1 plus 1.
Right, so xm will not go beyond this. So what is m here? N K1 is a natural number and m is less than n K1 plus 1. So this is actually the situation. So therefore, all terms now, forget about subsequence. You just think about all terms of subsequence after this nk1 term. Will in this neighborhood, same neighborhood, will they remain
Yes, sir.
inside a right? And therefore, what we wanted to find k, what is the obvious choice for k? We wanted to find k here. So what is the obvious choice for k?
K1.
uh, K1, but see, suppose K1 is 10 and therefore nk1 is n10, right? n10 could be some number which is suppose 100. Then can I say that ki xn minus alpha is less than epsilon for all n greater equal k1, that is 10? What we are sure? We are sure after nk1, that means 100. We are sure after 100 term. We are sure after 100 term. But we are not sure after k1 term. K1 is something smaller number, but nk1 is something larger. And we are sure about nk1 after nk1. Is it clear what I want to say? We are sure after 100 term. We are not sure about. This is not true for n greater equal 10, but certainly this is true for n greater equal 100. Am I right?
Yes, sir.
Right. And therefore, what k I should select from this? So choose k is equal to
K1 plus 1.
no, not k1 plus nk1. Nk1 is a particular number. Do you understand? Is it clear?
Yes, sir.
Nk.
Yes. Yes, sir.
Yes,
Suppose
sir.
if you look at a subsequence uh, x nk and nk is suppose 2k, and then what are the and suppose k1 is equal to 10, then what is nk1? That is n10. But what is n10? 2 times 10, which is 20. So after 20 it is true, right? And therefore nk1 is a specific number which is 20 in this case, right? And therefore natural choice for k is nk1, n suffix k1, right?
Yes, sir.
Right. So we have to be very careful while dealing with this such kind of things. See what is a K and what is K1 and when it is true. So deep thinking is required in this case. Right. Sometimes it is confusing, but you should spend some time to understand this kind of things. Anyway, so if you choose a K greater equal K is equal to N K1, then for N greater equal this K, right? N greater equal this K, what can you say about Xn minus alpha? Xn minus alpha.
It would be less than epsilon.
Right, so is it less than epsilon? Because why this is so? This is so because when I choose n greater equal k and k is nk1, right? And after nk1, every term will satisfy this, right? If n is greater equal k, it is greater equal this, and this is strictly greater than uh, k1, right? This is strictly greater than k1. So after that, all terms will satisfy this uh, criteria, right? So therefore, can I say that for every epsilon there exists k such that xn minus alpha is less than epsilon for all n greater equal k. Hence, limit of xn is also alpha, right? And when under what condition this is true? If sequence is monotonic and one subsequence is convergent to alpha, then entire sequence converges to alpha. This is what the point is, and we are going to use this result for finding limit of some sequences further. This is important result actually, because if you are sure that your sequence is increasing and if you want to find limit of some sequence, it is not possible to find limit of sequence directly, so it is sometimes possible to find limit of subsequence, right? And then that will be limit of the sequence. Correct. Is it clear why this result is important? What I said, ki sometimes we are sure that sequence is convergent and sequence is monotonic, but it is not easy to find limit of sequence, but it is possible to find limit of some subsequence, and that is the limit of original sequence because of this result, right? Again, recall the question which we discussed. Suppose xn is a sequence of real numbers. If xnk and xnr are two subsequences of xn such a limit as k tends to infinity of k tends to infinity of xn k is same as limit as r tends to infinity xn r is equal to alpha. Then can we say that limit of xn is alpha?
Yes, sir.
No, sir.
No, sir.
Answer is no actually. If you look at nk is equal to 2k and nr is equal to 4r, right? And my sequence xn is minus 1 raised to n, right? My sequence is minus 1 raised to n. Then what is xnr? What is xnr? x2r, xn k first of all, xn k. So it is 2k. And what is this sequence? 2k x2k minus 1 raised to 2k. What is it? 1, 1, 1. Am I right? Is it true?
Yes, sir.
Right.
Yes, sir.
What is limit of x and k?
1.
1. Now what is x and r? X 4r. So it is minus 1 raised to 4r. What is this sequence? Still it is also 1, 1, 1. So what is limit as r tends to infinity? X and r.
1.
Right. Therefore limit k tends to infinity x and k is same as limit r tends to infinity x and r, which is 1. But xn is not convergent. Right? Therefore, only two subsequences have same limit is not sufficient. Correct? Do you understand?
Yes, sir.
So therefore, only two subsequences have same limit is not sufficient. So every subsequence should converge to same limit. Then we say that the sequence is convergent. That is what the statement we already learned. But there are two specific subsequences, right? And there is a very interesting result. Suppose xn is a sequence of real numbers. Consider two subsequences x to n. Okay, what is the notation I should use? 2k and x to k minus 1. Right? Are these two subsequences of a sequence?
Yes, sir.
Yes, sir.
Yes, because if you look at x to k, that means what is nk here? 2k. And which terms we are capturing now?
Even.
Right, x even terms with even suffixes we are capturing. Right, and here
Yes, sir.
nk. So x 2k minus 1, that means nk is 2k minus 1. And in this second subsequence, we are just capturing odd terms, odd suffixes. Right, terms with odd positions. And here we are capturing terms with even positions. Right, that means x1, x2, x3, x4, x5. In first subsequence, we are just deleting. In second, we are deleting even. Whatever remaining is the subsequence. In second case, we are deleting odd. What remains only even. So this is new subsequence. So these are two subsequences. If and why these two subsequences are very special. These two subsequences only capture even suffixes and capture odd suffixes. What is your observation? Why these two subsequences are very special? What is your guess? Do you understand in previous example? In this example, what was my first subsequence? 2k, x2k, x2k and x4k, right? x2k and x4k. So it captures all the suffixes with even suffixes. It captures with even, but it captures only with multiple of 4. That means each capture this captures even, and it second also captures only the some even suffixes, not all. This captures all even suffixes. Correct. This is what. Now, what is the speciality of these two subsequences? What is your guess? You just observe this. x2k and x2k
They have no
minus.
common terms.
No common term, that is fine, but one more thing, first subsequence captures all even terms and second subsequence captures all odd terms, and these two subsequences together will capture all the terms of sequence. You understand this?
Yes, sir.
Right. So these two subsequences together will capture all the terms of sequence. That is not going to happen in this case. Do you understand? These two subsequences together will not catch all the terms of sequence. Right? Is it clear what I said?
Yes, sir.
Right, and that is the main point. If limit k tends to infinity x to k is equal to limit k tends to infinity x to k minus 1 is alpha. That means if these two subsequences are convergent, then limit of xn is also alpha. This is very interesting. That means these two subsequences are very special. In general, what was our question? In general, this is not true. Right? In general, answer is no, and we have examples. In general, answer is no. But if you choose a special subsequences, which are even suffixes and odd suffixes, these are very special. If these two subsequences converges to the same limit, then original sequence converges. So, right. So these subsequences are special. Is it clear? Statement is clear.
Yes.
Yes, sir.
Okay, so let us prove what is given. What is given data? So given data is x2k converges to same number alpha, x2k minus 1 converges to alpha, same number alpha, that is limit of x2k is equal to limit of x k tends to infinity x2k minus 1 is alpha. What is our claim? What is our claim? Right? This is our claim. So what we want, this is a claim means what we want. Yes.
For given epsilon, we want k.
So given any epsilon, we can produce k such that xn minus alpha is less than epsilon for all n greater or equal. This is our ultimate aim. So how to start the process? How to start the process?
Choose any epsilon.
So given, suppose epsilon is given. Now our job starts want k. So this is our aim. Now we want a k. Epsilon is known. We want k. Okay. So use given data. It is given data. So what is given data? So what is given data?
Limit of x to k and limit of x to k minus 1 is equal to 1.
Right. So since limit k tends to infinity x to k is alpha, by definition of limit, there exists k1 such that x to k, right, minus alpha is less than epsilon for all k greater equal this k1. Am I right? Whatever I have written is clear?
Yes, sir.
Right.
Yes, sir.
Because this sequence converges to alpha subsequence, and so for any epsilon we can produce k. So for this epsilon we found k1. Similarly, limit as k tends to infinity x 2k minus 1 is also alpha. For same epsilon there exists k2. There exists k2 such that x2k minus 1 minus alpha is less than epsilon for all k greater equal k2. Fine. So what is then k which we wanted to find? What is k? Right? What is the required k? Yes. So what
Maximum of
first?
nk1 and nk2.
Okay, that is right. So okay, just 1 minute. Okay. So what is the proper choice? So what first statement says? Okay, so what first statement says ki this is first and this is second. So what first statement says ki k greater equal k1. That means what is the corresponding suffix here? If what is the least choice for k1? That means x2 k1. This is the least choice for k, and this onwards all terms are in this distance alpha minus epsilon to alpha plus epsilon. Right? Am I right? What I am saying?
Yes, sir.
Yes, sir.
And what second statement says ki after k greater equal k2, that means what is the least choice for this suffix here? What is the least choice?
x2 x2k2 minus 1.
It's x2 k2 minus 1. After this suffix, all odd suffixes are in this range alpha minus epsilon to alpha. All odd suffixes. That means for if you choose k greater equal k2, you will generate all odd suffixes, and all odd suffixes. All the terms after this term, right? All the terms after 2k2 minus 1, after this term, all odd terms are in this distance epsilon alpha minus epsilon, and all even after this, and therefore after which all even as well as odd in this range. Do you understand? Okay, after this term, all odd terms are in this range, and after x2 k1, all even terms are in this range. Therefore, after which term all even as well as odd are in this range. Is it clear?
Maximum of nk1 and nk2.
Right. Therefore, choose k is equal to maximum of 2k1 and 2k2 minus 1. If you choose maximum, then either it is even or odd, right? Then for n greater equal k, what can we say about xn minus alpha? So if n greater equal k, if maximum is suppose 2k1 or 2k2 minus whichever, it doesn't matter. And if I choose n greater equal k, that means what? N is greater equal k and k is greater equal to k1 as well as 2k2 minus 1. Right, when I say n greater equal k, then n is greater equal to k1 as well as 2k2 minus 1. Now if your n is even, then ultimately it is greater than 2k1. That means it is after this term. So it is in epsilon minus epsilon alpha minus 2. If n is odd, then it is greater than 2k2 minus 1 odd. So all odd with after this are in this range. So all n. Is it true? Is it less than epsilon?
Yes, sir.
So it is
Yes,
less
sir.
than epsilon. Right, and therefore no, it doesn't matter it is even or odd, all terms satisfy this. Therefore, given epsilon, there exists k such that xn minus alpha is less than epsilon for all n greater. Hence, limit of xn is also alpha, and therefore these two subsequences are very special because they cover all the terms. These two subsequences captures all the terms. That's why these two subsequences are important. In general, the result is not true, right? In general, two subsequences are not sufficient. But if these two subsequences are giving same converging to same limit, then no problem. Original sequence converges to the same number. Right. Now, there is one more criteria, which is called as a Cauchy criteria. So Cauchy was a mathematician, and he did a lot in analysis, right? Basically, this kind of analysis, sequences, limit, defining the definition of limit, all these things. So what is its criteria? So a sequence xn of real numbers is said to be Cauchy sequence, right? So a sequence like a monotonic increasing sequence, monotonic decreasing sequence, bounded sequence. So similarly, Cauchy sequence. A sequence xn is of type Cauchy sequence if given any epsilon, there exists k such that xn minus xm is less than epsilon for all m and n greater equal k. What does it mean? What is the meaning of this definition? Do you understand the meaning?
The terms are getting closer to each other.
Right. That means you give me any distance epsilon. If this distance is epsilon, if sequence is Cauchy, then given any distance epsilon, I can find k. K onward, you choose any two terms, right? For all mn greater equal k means what? Suppose k is equal to 10, and after k mn greater equal 10, that means if I choose m is equal to 15 and n is equal to 23, then distance between x15 and x23 is less than epsilon. That means uh, if I choose m is equal to 100 and n is equal to 5000, then also distance between x100 and x5000 is less than epsilon. Right. So that means after k, you choose any two terms, no matter what terms you which terms you select after 10 term, their distance is less than epsilon, whatever is epsilon. If you change your epsilon, if you choose some smaller epsilon, then there is some k. That k may be larger. Suppose that k is 100. So after 100 term, you pick up any two. Just close your eyes and choose terms after 100. Their distance is less than epsilon. They are in this distance. That is what the meaning is this. So that means whatever is the epsilon, whatever is number epsilon, terms are in that distance. So terms are getting closer after certain stage, right? After certain stage, all terms are in epsilon distance from each other. This is what the meaning of Cauchy sequence. And this criteria is useful because sometimes Cauchy criteria gives the convergence. So that we'll see later on. But anyway, let us see first example. So let xn is equal to constant sequence for all n. Then what is xn? A constant sequence. So is it a Cauchy sequence?
Yes, sir.
Right? So it is Cauchy sequence because given any epsilon, right? Epsilon is any some positive number. You can say epsilon is 1 by 10, whatever. Then what is the choice for k? If you look at any two terms, xn minus xn, but every term is c constant, 0 less than epsilon. Am I right? Whatever terms you select, the terms are constant. So it is 0 less than epsilon. Epsilon is a positive. So xn minus xm is c minus c, which is 0 less than epsilon for all m and n greater equal 1. Here in this case, k is equal to 1 works, right? Is it clear what I said?
Yes, sir.
Yes,
So
sir.
let xn is equal to 1 by n. Now question is, what is our sequence? 1 by n. So is Cauchy sequence. Is it a Cauchy sequence?
Yes, sir.
So let us try to prove this. So given epsilon, can you produce k such that distance between xn and xm, or 1 upon n minus 1 by m, is less than epsilon for all m and n greater equal k? Right, this is a question. Given epsilon, can you produce k? Right, and what is that k? So let us consider epsilon is given. Now we want to produce k, and let us see whether we can produce. So consider xn minus xm. Try to simplify this. So 1 upon n minus 1 by m. Right, this is less than or equal to 1 by n plus 1 by m. Am I right? By triangle inequality. Yes.
Yes, sir.
All 1 by n, 1 by m are positive, so no need of absolute value sign. Right. Now suppose, so if n is equal to m, So note that if n is equal to m, then what is xn minus xm, which is 0 actually, right? Less than epsilon. So n is equal to m is not an issue. What we are worried if n is not equal to m. Right? If n is equal to m, then different distance between two terms is always 0. Right? That is not a non-trivial. So this is a trivial situation. So if n is not equal to m, assume that uh, m is greater than n. Suppose m is one of them is greater, another is smaller, no matter which is greater, which is smaller. So anyway, if they are unequal, then one of them is bigger, another is smaller. Whichever is bigger doesn't matter. Then what is xn minus xm is less than or equal to 1 by n plus 1 by m by previous calculations. So if 1 by m is if m is greater than n, then 1 by m is less than 1 by n. Am I right?
Yes, sir.
And therefore 1 by n plus 1 by n, which is 2 by n. Correct? So that xn minus xm will be less than epsilon if, suppose you want to make this difference less than epsilon. When it is possible if do you understand?
Yes, sir.
And so what is the choice for k? What is the choice for k? Right, from previous step, previous discussion, we can guess ki what could be the proper choice for k.
2 by epsilon.
Is it equal to 2 by epsilon? Is it correct?
Greater
When greater
greater.
than. Because 2 by epsilon may not be natural number and we want k to be natural number, right? So choose any natural number bigger than this. Then is it the correct k if m and n greater equal k and m is greater than n? If m is equal to n, not an issue. Or n is greater than m, same thing, right? If mn greater equal k and m is greater than n, then see what happens xn minus xm, which is less than or equal to 1 by n plus 1 by m, which is less than 2 by n, and it is because when I say m is greater than n and I am choosing n greater equal k, so ultimately 1 by and k is greater than 2 by epsilon, so ultimately n is greater than 2 by epsilon, so what 2 by n is less than epsilon. So this is actually the reverse process of this previous. So what is the conclusion? So given if n is greater than m, then I can say that here I will get 2 by m and ultimately m is greater than k, so this would be less than epsilon. So no problem. Same thing. Given any epsilon, there exists k such that xn minus xm is less than epsilon for all m and n greater equal this k. Is it clear? Hence is a Cauchy sequence. This is a Cauchy sequence. Let us see another example to prove whether it is a Cauchy. So let xn is equal to, for example, 1 by n square. Prove that xn is a Cauchy sequence. Xn is a Cauchy sequence. How will you prove? How to start the process? Given epsilon, what we want, k, right? Now, first of all, try to simplify the for m greater than n, consider xn minus xm or xm minus xn. Because of absolute value, it doesn't matter, which is 1 by n square minus 1 by m square. By triangle inequality, right? By triangle inequality, 1 by n square plus 1 by n square m square. But I am assuming m is greater than, so 1 by m is less than 1 by n. So 1 by m square is less than 1 by n square. Is it correct?
Yes, sir.
Right. And therefore this is less than or equal to 2 by n square. And so what is the choice? Right. If you want to make xm minus xn less than epsilon, we should make 2 by n square less than epsilon. That means n square is greater than 2 upon epsilon. That means n is greater than root 2 by epsilon. This is, so what is the choice? So choose k belongs to n and k is what?
Greater than root 2 by epsilon.
Right. And now verify that. Then if n greater equal k, then now check that xn minus xm is less than epsilon, like previous situation. So you can easily check this. Right. So look at another example. Let xn is equal to 2n plus 3 upon 5n. Now prove that xn is a Cauchy sequence. Prove that xn is a Cauchy sequence. Right. So how to prove this? How to prove this? So given epsilon, what we want, k, such that xn minus xn is less than epsilon after k, right? Okay, so consider xn minus xm. Just simplify this so that we can guess the value of k. What is 2n plus 3 upon 5n minus 2m plus 3 upon 5m. M and n are numbers, right? Distinct numbers. Suppose m is greater than n. Right. If m is equal to n, then difference is 0 less than epsilon. That is not a difficult point. Okay, let us simplify this. Let us try to simplify this. So what we will get? 5 is common. So I will multiply here m, cross multiply and multiply here by n. So what I will get? 2mn plus 3m minus 2mn, right? What is it? Minus 3n. Am I right? You check the calculations. Is it correct?
Yes, sir.
Yes, sir.
So I have just cross multiply. So 2m and 2m get cancelled. So 3 times m minus n upon 5mn. But I am assuming m greater than n. So m minus n is positive quantity, right? 3 m minus n upon 5mn. Right. Can I say that, see, m minus n is positive quantity and m minus n is less than m? Is it true?
Yes, sir.
right? This is just simple observation. So certainly this is true. So what I can say here, therefore I can say that this is less than 3 times m upon 5m n, and ultimately what is this 3 by 5n, correct?
Yes, sir.
Xn minus xm I have simplified in this way. And so what is the choice for k? K greater than what?
3 by 5 epsilon.
So ultimately we want to make 3 by 5n less than epsilon, so that xm minus xn would be this. So n greater than 3 by 5 epsilon. So 3 upon 5 epsilon. Right, so epsilon is given, and calculate this number and choose k greater than this. Therefore, if m and n greater equal this k, then you check that xn minus xm, this difference is less than epsilon. Right, so this is true because this is a required correct k. You just go in reverse way like this, you will ultimately reach to this. Therefore, given epsilon, there exists k such that xn minus xm is less than epsilon for all mn greater equal k. Now, which sequences are Cauchy sequences? How can I say that definitely this is a Cauchy or not? Why 2n plus 3 upon 5n? Why I am sure that it is a Cauchy, right? How I am sure? So, if xn is a convergent sequence, then it is Cauchy. Right, so every convergent sequence is a Cauchy. That is, sequence is Cauchy. So in this previous example, okay, is this sequence convergent? Is this sequence convergent?
Yes, sir.
And what is limit of this sequence?
2 by 5.
2 by 5, right? So this sequence is convergent, therefore it is Cauchy. That's why I was sure it is Cauchy. That's why I said that prove that it is Cauchy. So if sequence is convergent, then it is certainly Cauchy. And proof of this theorem is very easy, right? So what is given? Suppose what is hypothesis? Xn is convergent. Suppose xn is convergent, therefore it has a limit. So let x is equal to limit of xn, right? Suppose limit of this sequence is x. What is our claim? What is our claim? Xn is, this is our claim. That is, what is our claim? Given epsilon, there exists k such that the distance between any two terms after k is less than epsilon. This is our claim. Is it clear? Right?
Yes, sir.
So how to start the
Yes, sir.
process? Given epsilon, want to produce k. Okay, so how to produce k? But what is hypothesis? Ki limit of xn is x. So since, so give epsilon, we want to produce k such that this condition will be satisfied. But since limit of xn is x, for any epsilon there is k. In particular for this epsilon there exists k such that xn minus x is less than epsilon for all n greater equal k. Is it right? Is this correct? Whatever I have written. Yes.
Yes, sir.
Now, what is the k which you wanted to produce? What is the proper choice for this k? Is it the same k which we found for a limit of xn? Will same k work? Let us check. Suppose m and n are greater or equal this particular k, right? Then check whether xm minus xn is less than epsilon or not. Then what is xn minus xm? If it is less than epsilon for each m and greater or equal same k, then we are done, right? So xn, I will just add and subtract x in between. And what are m and n? M and n are greater or equal k. That's what I must. By triangle inequality, xn minus x. Am I right?
Yes, sir.
Okay, I will make some adjustments. So since limit of xn is equal to x, so for epsilon 1 is equal to epsilon by 2, I will select half of it. Then also there is k, that k I am using, so I can say that this is less than epsilon by 2. Is there any confusion? It is fine. If I start with epsilon by 2, then I will get some k. No problem. Why I am making these adjustments? Because I come across something like this. Okay, now where is n? N is greater equal k, and if n is greater equal k, that means if your suffix is greater equal k, the difference is less than what? If suffix is greater equal k, then corresponding term xn minus x, the distance is less than epsilon by 2. So look at this bracket, xn minus x, and where is n? N is greater equal k. Can I say that this distance is less than epsilon by 2?
Yes, sir.
Yes, sir.
Okay, what about xm minus x? Where is n? Where is this suffix? This suffix is
It
also
is
greater
greater than
equal,
k.
right? So this suffix is also greater equal k, and once your suffix is greater equal k, the corresponding difference is less than epsilon by 2, which is epsilon. That's why I started with epsilon by 2. So at the end I will get epsilon. This is adjustment, and we are not forcing or not violating any rule. Key for every epsilon there is k, in particular for epsilon by 2. This epsilon is fixed. This is a particular number. I will take half of it, which is again positive. For that number also there is k, right? So therefore, given epsilon, there exists k such that xn minus xm is less than epsilon for all mn greater equal k, and hence xn is Cauchy. Right, and therefore once sequence is convergent, it is very easy to see that it is Cauchy. Right, the question is converse true? That means if sequence is Cauchy sequence, is it convergent? Okay, so we'll think about this question next time. Yes, so if